He is a BTech in Industrial Chemistry from Abubakar Tafawa Balewa University, Bauchi, Nigeria, MSc in Analytical and Instrumental Analysis from the University of Malaya, Malaysia, and a PhD in Environmental Analytical Chemistry from the University of Aberdeen in the UK. He has experience and skills in the practical application of analytical chemistry, method development and quality control techniques, state-of-the-art instrumentations, and peptide de novo sequencing using HPLC coupled to Orbitrap MS and use of PIC and muscle software for protein identification. He has conducted a number, many different work which has been published in many great journals like Scientific Reports, and he has also worked in the area of metal speciation in biological and environmental sampling using a number of different techniques. Dr. Mohammed Musa Lawan is currently the Deputy Vice Chancellor Academic in the Yobe State University, and he has been an instrumental part or member of the team helping to set BioRTC. So without wasting much time, I would like to invite you, Doc, to give your presentation. Thank you very much.
Thank you very much, Dr. Mahmoud, for the introduction. I would first like to apologize because I was listening to Maria's talk up to the point when she said, I'm done. And suddenly my network also said to me, I'm done. Selenium, the two first trace element, this is actually part of the work that I have done during my PhD, part of the research. And the reason why I choose to talk about this topic is I had some questions in my mind when I went in order to develop method for the determination of these trace metals in plant and animal. Then suddenly certain questions now pop in, and at the end, the question now landed me into two major collaborations. And that is why I choose to talk about this, just to show how important a collaborating research is, and how it shortens the times of one's research rather than just working alone in a silo, working in your own lab. It's better to have a team of experts that are sharing almost some points in terms of your research, that you can come together and support each other in terms of getting your work done, and in terms of getting holistic in quotation, maybe ideology regarding the research. Selenium is actually an essential nutrient. It was first discovered as a toxin, and it later metamorphosed into an essential element, a trace element for that matter, that is needed for proper maintenance of health in both human and animal. So many of the health-related systems in humans and animals depend largely on selenium and selenium protein functions. And various studies have already suggested that selenium can improve the fundamental immune system in both plants and animals. But the bigger question is that, yes, selenium can do such a thing, but it is also toxic as well as essential. So because there is a thin border between its essentiality and toxicity, that consumption of food containing around 0.1 microgram or ppm, let me just use this term, ppm, can lead to toxic manifestation, which would later lead to something that is called Kishan disease. Kishan disease is a cardiomyopathy disease, kind of. From the picture here, you can see this is a heart of a cardiomyopathic patient that is as a result of selenium deficiency. While consuming food containing 1 ppm of selenium can lead to a disease called Cushing-Beck, which has more to do with muscular dystrophy, as you can see from this picture. What are these sources of selenium? Because we can only get this through dietary sources. What are the sources? The picture here is showing some of the dietary sources where we can get selenium from. You can see the eggs, the liver, the fish, the red meat, and the nuts. So these are the some of the sources of selenium. And selenium gets into our food chain basically from the soil through the plants, from the soil where the plants are grown, then it goes down to the food chain. How does it work? That's another question. So because of this thin line between toxicity and essentiality, it now becomes an issue, and it becomes very difficult for the regulatory body to determine what the required concentration or this required level can be for humans. And as such, because of this thin line, then the EU now recommended that 0.5 ppm should be added to a finished product. That not considering the background concentration, the possible background concentration in the feed or the ingredients of the feed. What does it do? It exists in different forms: selenocysteine, selenate, selenite, selenoprotein, selenocysteine, selenomethionine, which is the organic form of selenium. It exists in this form in various food products. What does it do? It does quite a number of things. It regulates the immune system. It regulates the thyroid glands. It's an antiviral. It provides antiviral activities, anti-heart disease, anti-diabetics, anti-aging. It improves brain function, anti-cancer, anti-asthma, arthritis, muscular dystrophy, cystic fibrosis. It also improves fertility as well as boosts immunity, and many more other functions that it does. So now the question now changes from actually just looking at the concentration to what happens. How does it transform? We move from actually looking at the concentration in the food. Now we want to see what is the biotransformation process? How does it biotransform in the system? Because of the collaborative ideology, now we all came from the chemistry background, environmental chemistry. So it is quite difficult for one to just house human and say, okay, yeah, I'm going to put you on this particular food or supplement and monitor you. Then later I collect sample. It's very difficult for humans to do that. Then we decided that, okay, let's go for fish. Why not go for fish? Since it has a larger proteome as compared to humans. So then we now collaborated with fish immunology group at the University of Aberdeen. They're interested in looking at the effect of selenium supplementation to the fish, looking at the chemical activities in there. So in order to understand the biotransformation, because it was not quite new, but it was relatively new to the field of research. So as such, the biotransformation process or steps are quite not clear. But because of its similarity that it has with the sulfur, then it is quite easy for the scientists to now say, okay, let's see, because they share quite a number of chemical properties, as well as it has also strong affinity to sulfur. Then there's every tendency that it follows the biotransformation process of the sulfur. So what you see here is the biotransformation process of sulfur that was adapted to be the biotransformation process of selenium. And actually, it does follow almost the same thing. So here, what we did, the methodology or the experimental design, what we did, we housed about more than 200 fish, rainbow trout fish for that matter. Then we formulated the supplement. We measured the background concentration, possible background concentration of selenium, as well as we added different concentration, and we grouped them into four different groups. We have the acclimatization group, we have the control, we have the one spiked with 0.5 ppm, 4 ppm, 8 ppm, just to see at what level, because of different reasons for our experiments, because they are looking at the immune system. So that's why we go up to this percentage, but actually it's not it's okay. So that's why we moved to this higher. So we had some time points, and after the time point, we do sample the fish, we collect them, and collect blood sample, collect liver head, we collect the kidney, we collect the muscle, as well as the gills of the fish. So these are some members of the team. That is Stewie, we have Faciti, Davide, and that's my table actually, busy doing photography work at that moment. Then, after collecting all these samples, then we carry out this analysis. They are interested in looking at the biological analysis, on which they look at they carry out qPCR screening to see the selenium genes expression and modulation of the immune-related genes. Then while on the other part, I was looking at the chemical analysis on the diet. Then we looked at the total concentration in the fish after feeding. We look at the different species of the selenium. That is looking at the biotransformation. What happened? We have supplemented with this with selenium methionine. Now at the end, we want to see the transformation. To what forms had the selenium transformed? We looked at that, and we also look at the possible incorporation of the selenium into the selenium protein that contains the analog of cysteine. Then that is why we even incorporate to have selenocysteine, which is an essential amino acid now being considered to be the 21st amino acid. So basically they looked at bioactivity, then I focused more on the bioavailability. What did we do in the bioavailability? We determined the total to look at the hotspots of the selenium. Then we carry out enzymatic analysis just to see to see the different species. So to see the different species, and we also carry out another enzymatic activity, in this case to carry out the de novo sequencing, just to determine the possible incorporation of selenium into selenoprotein or into the process of generating selenoproteins in the system, which are the key things that are responsible for all the functions that we showed that selenium is doing, because selenocysteine is the active ingredient of most of the enzymes, like the glutathione, thyroidexin reductase, all of them, they have selenocysteine as the active ingredient of those enzymes. So what do? We do extraction, enzymatic extraction. In the end, what we do, we couple 3 different instruments. We have the HPLC where we carry out the separation. Then we have the electrospray mass spectroscopy where we determine the molecular, we get the molecular information. Then we have the ICP-MS that give us the elemental information. In the end, we get the chromatogram from the molecular information as well as the elemental information. We overlay the two, then the elemental information show us the region where we have selenium compound. Then we focus on that. We look at the MS and MS just to determine the identity of the compound. This is just a chromatogram just to show how the method we developed was able to achieve good separation of the different form of selenium species. So in the end, we did the de novo sequencing. Then after blasting, we were able to get match glutathione peroxidase. But when you look at it very carefully, you will see that the percentage match is quite low, because largely the selenoproteins that we have within that very short period of time were actually smaller when it comes to the size of the peptide. So basically, that's one of the we just achieved quite a little in this aspect, because the time taken wasn't enough for the synthesis of selenoprotein, bigger selenoprotein that we anticipated, which is the selenoprotein P. But at least we were able to get some idea that is actually working, and we have also seen from the biological activities how some of the genes were down up-modulated, while some were down-modulated after supplementation with selenium up to that level. So the findings are that we find high concentration in the liver, then followed by kidney, gills. So these are the hot spot. And the good news is that we have just an appreciable concentration level in the muscle, which is basically the part that most people are consuming, and which we assume that is substantial, is enough to give to contribute to the immunity of both human and animal, because what we have seen there, after increasing all the concentration in the diet, we'll see that from the 0.5 down to 1 ppm, then we got quite a good response from the fish, because there was no lesion and they were very active and their growth was quite good. So we concluded that that concentration is quite good and enough to actually to maintain normal homeostasis in the body. We also look at this from the speciation. We now realize that yes, of course, some of the species of selenium, the methionine, was actually transformed into selenocysteine, which is the most important form that we are quite interested in. And it turns out that we have the two. We have the selenomethionine, which contributed to the selenomethionine pool in the system, then followed by selenocysteine, which is what we are actually interested in. And it then shows that selenocysteine has actually been synthesized in the body through the process we anticipated. Then we also...
Doc, if you can start running, Doc.
Yeah, I'm about to. Yeah, so after doing that, we also employed the method also because there were some long pilot wells that were stranded, and a lot of scientists now coming that what could be the reason for their stranding. Then a lot of scientists now came in with us looking at the possible toxicity, maybe possible intoxication by mercury and other heavy metals. So we did that. In the end, we actually get one of the biotransformation stages whereby selenium actually detoxifies the effect of methionine, and that we find a very good result in the brain of the pilot whales. And most of these findings, and this is the finding that was actually, because it is a new thing that we were able to establish, and it was published in Nature in 2016, and most of these findings were published in PLOS ONE, Biomedical Central Genomics, as well as scientific report. An acknowledgement to the team. And I also appreciate the Altec, because the other site was sponsored by Altec. Then the Fish Immunology Group, our lab, which is the Trace Element Speciation Laboratory, as well as the University of Aberdeen, because they supported this interdisciplinary research with about £3,000 to support the research. And to the chief host, Mohammed, thank you all for giving me the opportunity to make this presentation. And this is just to show you that we are open to collaboration. And as you can see, what selenium can do in terms of improving brain function, which is most of part of the thing that you're working on. I actually wanted to add a paper that I saw that has to do with Alzheimer. It was quite a new paper. Then we'll talk about that later. Thank you so much.